For this question, we're given this function y is equal to x minus 4 over ax squared plus bx plus c. A, b, and c are non-zero constants, and we're given some information here. There's a local minimum at the point 2, 1, a vertical asymptote at x equals 1, and we need to find the values of a, b, and c. Okay, so we've got three unknowns, so we need to make three equations, and we're actually given three pieces of information. So we're told when the derivative is equal to 0, that's at the point 2, 1. We know it goes through the point x equals 2 and y equals 1. And we know there's a vertical asymptote at x equals 1. So therefore, we've got enough information to make our three equations. Okay, so if we know we've got a vertical asymptote at x equals 1, that means the denominator is going to be equal to 0. So we're going to have this ax squared plus bx plus c must be equal to 0. We know that happens when x is equal to 1. So therefore, just plugging in 1 into that, we're just going to get a plus b plus c is equal to 0. Okay, so there is one equation done. And for another equation, we know it goes through the point 2, 1. So we know when y is equal to 1, then x is equal to 2. So we're going to get 1 equals 2 minus 4. And that's going to be all over a times 2 squared. So 4a and then 2b plus c. And then just rearranging that, we're going to get 4a plus 2b plus c is equal to 2 minus 4, which is negative 2. Okay, so now I've got two equations. We can go about getting the third equation. So for the third equation, we can take the derivative of y with respect to x and set it equal to 0. So we'll do that. So we get dy by dx is equal to, and we'll just use the quotient rule. So it's going to be the denominator. So ax squared plus bx plus c times the derivative of the numerator, so, which is x minus 4. So the derivative of that is just 1. And then we subtract what was in the numerator, so x minus 4, and then times the derivative of the denominator. So we're going to get 2ax plus b, and then all of that is going to be over the denominator squared. So we get ax squared plus bx plus c all squared. Set that equal to 0. Okay, so then we're going to get ax squared plus bx plus c minus x minus 4 times 2ax plus b is equal to 0. And now we can just plug in x was equal to 2 at this minimum point. So then we get 4a plus 2b plus c, and then subtract. So x minus 4, 2 minus 4 would be negative 2 times 4a plus b. I'll just write out each step here. So 4a plus 2b, and then minus. So I'll make some brackets here just so we don't make any mistakes with the sign. It's going to be minus 8a minus 2b, and simplifying it, and that's all going to be equal to 0. And then we're going to get 4a plus 2b plus c plus 8a plus 2b is equal to 0. And then finally, we're going to get 12a plus 4b plus c is equal to 0. Okay, so that is our third equation. So now we can just go about putting this into our calculator. Okay, so we'll bring the calculator up. And we're just going to go to algebra. systems of linear equations, and we've got 3 equations there. So x, y, and z. So we'll just type in the equations. So one of the equations we had was a plus b plus c equals 0. So we'll put in x plus y plus z is equal to 0. The next equation, we had 4a plus 2b plus c is equal to -2. So we'll get 4x plus 2y plus z is equal to -2. And the last equation, we had 12a plus 4b plus c equals 0. We get 12x plus 4y plus z is equal to 0. And then we can solve that. And we have the answer there. So a is equal to 3, b is equal to -11, and c is equal to 8. Okay, so we can just write that in. We end up getting a is equal to 3, b is equal to -11, and c is equal to 8.